Welcome back to the next Unit 2 video. As you can see, today we're going to look at applications that make use of the internet. So just a quick overview then, we're going to just recap the internet versus World Wide Web. Yeah, I think we looked at that a couple of times already. Then we're going to look at cloud computing, right, the advantages, disadvantages. We're going to look at the two different types of clouds, right, private and public. And finally, we're just going to look at bit streaming, so real-time on demand, yeah, the advantages and disadvantages of each. Alright, so yeah, just to recap then, hopefully people remember this, the difference between the internet and the World Wide Web, or WWW. So I think we can say, the World Wide Web is going to be a collection of web pages linked together and accessed via the HTTPS protocol. And of course, again, HTTPS, the Hypertext Transfer Protocol, and that's going to mean secure. So of course, when it says web pages linked together, that means from one web page. Of course, that page might have a link to another page. That page is going to have a link to another page, right? So yeah, all the pages are linked together. Right, the internet, that's going to be an internet network. It's the worldwide connection of devices and infrastructure. Right, for example, the cabling, the satellites, the routers, etc. It's going to communicate over IP, and any digital data can be sent. So that can be web pages, media, so audio, video, emails, files, programs, text, just etc. So what we can say, the internet is a superset which contains the World Wide Web. And then I think, this Venn diagram we've seen, right, if you've seen the previous video, but again, just to recap, so the World Wide Web, of course, that's just web pages, right, obviously access via HTTP, right, or HTTPS. Whereas everything, the internet, of course, that's going to include, right, all of this, right, and a lot more as well. Obviously, clients, that's going to be the end device, right? Maybe the mobile phone, the laptop, I don't know, the car, right? I guess some self-driving car, it could be anything. Obviously, servers, that's going to be something that kind of handles a request, right? It's going to respond to a request. So that could be a web server, but it could be a file server, a database server, some video streaming server. TCP, UDP. Now, actually, these are not really required for AS. But what you, really, right, these are more A2 topics. But if you do want to know, TCP, this is just going to ensure reliable communication. And I think, even though you actually don't need to know, TCP itself, I guess you kind of do need to know what TCP does. So TCP, there's going to be two things. One, right, if packets arrive in the wrong order, it's just going to make sure to, reorder them, right, put them in the correct order. And two, if any packets don't arrive, then it's just going to basically ensure that the packets are resent, right, until all the packets do re-arrive. Until all the packets do arrive. That's what TCP is going to be used for, right, just reliable communication. Now, today, today really we're going to look at UDP, right, in particular, for the video streaming, which we're going to look at in a minute. So UDP basically, that's just going to send the data, right? Then it's not going to check. So maybe the data arrives, maybe it doesn't. Maybe the packets arrive in the correct order, right? Maybe they arrive in the incorrect order. UDP, it's not going to check. It's just going to send the data. And of course, while UDP is of course going to be less reliable, right? The advantage of UDP, it's going to be faster because it's not having to do these checks. And like we said, something like a phone call. Like if, for example, you have, I don't know, okay, right, let's say you have packet 3 that arrives, but for example, packet 2 doesn't arrive. Well, the thing is, you can't sort of go back and, ask for packet 2 to be resent, because by the time, you've actually sort of received the resend of it, then, by that point, of course, so I guess by that point, of course, the audio of packet 3, that's already played. So that's the thing, when you're talking about real-time connections, you can't really be using TCP, right? It's going to be too slow. I think infrastructure cables we mentioned. One, of course, emails, files. Then things like SSH or Telnet, basically just logging into servers remotely, just kind of accessing a server via a terminal. Alright, so if we look at the first new content, then cloud computing, and this is probably a term that people have heard a lot. So for a definition, it's going to be the provisioning. And I guess provisioning, that means, acquiring, or kind of maybe just say the using, the renting, right, the allocating, right, of computer service, of computing services via the internet. That's quite a general definition, but yeah, I think that's, quite a good definition, really. Right, so we say, clouds can be either private within the company or public. And some public clouds, people probably know some of these. AWS or Amazon Web Services. And that's probably 70% of the entire cloud. Most of it is going to be AWS. Baidu, right? Azure, right? So Microsoft Azure, Alibaba, Tencent, of course Google, right? Google Cloud. And yeah, I mean, I guess here's just a list of some of the common ones. Again, AWS, right? Google, Azure. Yeah, I mean, probably some of these others people might know as well. All right, so it seems, yeah, that's in the wrong order, but right, okay, so here then it says for the private cloud option, there's going to be three choices, right? Either the organization creates and manages their own on-site cloud. So I mean, I guess yeah, this is kind of going to lead on to this question, so I won't say the answer yet. Right then, two, well, yeah, right, okay, yeah, or the organization could outsource to a third party, and this third party, right, so I mean, this other company would then create and manage the on-site cloud. So I mean, in that regard, like okay, so when we say an on-site, so right, okay, I don't know, right, let's say this is company A. So of course, what either company A, they can create and manage their own cloud themselves, right? Or they can, for example, get company B. So of course, well, they can pay company B, and then company B can, I guess, kind of set up a private cloud, within the premise, yeah, of sort of company's A building. And I mean, like probably in a minute, well, yeah, have a think about why they might want to do that. All right, then three, well, the organization could outsource to a third party, and this third party would create and manage an off-site cloud. So, of course, in that case, well, rather than having I guess, yeah, A and then obviously B creates the on-site cloud, well, in that case, obviously, they're going to create a cloud, let's say, in B's headquarters. Then, of course, what A is then just going to connect to that, right, when they want to access the data. So let's think then, which of these would be, well, the most to least private? And okay, right, yeah, it seems I clicked it right already, showing the answers. I mean, hopefully it's quite obvious though. Of course, well, one is going to be the most private. I mean, the organisation is creating and managing it themselves. Two, I mean, well, they're keeping it on site, so that's going to be private. But of course, they're actually outsourcing the, so well, I guess, yeah, setup and maintenance to a third party, right? So slightly less private. Then, of course, well, this one, what they're outsourcing again the setup and maintenance to a third party, right, and it's also being managed off-site. So again, obviously this is the least private of all of them. However, the thing to notice, okay, like this is still all considered private, and the reason it's considered private is because, well, in this case, right, all right, okay, so what we can say, well, right, this cloud is made just for this company, whereas if we look at public clouds in a minute, well, I mean, these clouds, right, these servers, yeah, these computing resources, right, they would be shared by many different companies, right, many different users. Whereas yeah, okay, so even in this case, right, even, situation three, right, of course, I mean, the cloud is still going to be just for them, right, even though it's actually right in a different location. Right, so yeah, let's see this, like, why would they want to do this then? So the organization outsourced to a third party to create and manage an on-site cloud. All right, so have a think, right, why a company might want to do that. So if you've had to think, well, what you can say, if the company is small, then they probably won't have a specialized team that has the skills, right, or time to create and manage the system. I mean, and I actually, well, I mean here, like probably price as well, right? Yeah, I guess the money, right, the funds. Because if you're paying, I don't know, a group of like 2 or 3 people to manage this, then I mean, obviously it depends on the country, but I mean, some countries, well, let's say America, I mean, you're going to be paying each of these people like probably $100,000 a year. So having 3 people manage this, I mean, of course, well, that's like $300,000. Yeah, it's going to be a lot of money. So I guess instead of that, well, they can outsource to a third party who, of course, well, yeah, I mean, they've got the specialists, right? They have the experience. They can probably come set it up quite quickly, and I guess, yeah, probably that's going to be cheaper. And of course, if they do this, so yeah, even though third party is going to be slightly less private, at the same time, they're still getting the benefits of an on-site cloud, which, well, possibly that's going to be more secure. I mean, definitely it's going to have lower latency because, of course, what the communication is traveling a shorter distance. Yeah, if we're just talking about it being accessed from inside the company. And probably it's also going to be more customizable because if you're paying someone to come and, create a cloud right in your sort of on-premise location, well, you can, of course, tell them, well, I guess you can tell them, well, right, we're going to need this many CPUs, right? We need this much RAM, right? We need this, I don't know, yeah, this many like GPUs, yeah, whatever I guess, yeah, whatever hardware you need, you can of course just tell them, right, and then yeah, this company will come in, right, buy it all, set it up. Whereas if, for example, you're using like a, I guess, yeah, offsite or in particular public cloud, well, then it's going to be less customizable, right, in terms of the hardware, and yeah, the sort of configurations. Then if we go on to public cloud, it says, well, in contrast for public cloud, the user company only has one choice, and that's to use the cloud provider's infrastructure. So again, well, of course, that can be what AWS, Microsoft, Google Cloud, right, etc. So in this situation, customization is more limited, or yeah, maybe not possible entirely. And even if it is possible, like it's probably going to be more expensive, since well, of course, yeah, you're having to pay this other company. You know, they're probably not really set up for this customization. I mean, well, unless you're like a super big company. All right, so if we look at some of the cloud services, then well, the services provided by these cloud companies, and I suppose if you just look at this, I mean, well, the actual services can be overwhelming, and like I mean, here this is just on the featured products page or tab. Like if you go, for example, well, to this one, this one, this one, I mean, like each of these, they're also going to have like 10 or 20 different options. So it's just a huge amount. So this is why, I mean, some people actually say that like, right, if you're hosting a website, you know, some people say, well, using the cloud is sort of simpler than just using a traditional server. But I mean, in my opinion, like I would probably disagree. So I mean, again, you know, just like look at all the features they have. Whereas, yeah, I think sometimes just to set things up yourself. Whereas in some ways it's simpler. You know, you also learn more by setting things up yourself as well. But yeah, to be honest, right, that's going off topic. That's only for people if they're interested in, you know, making a website, right, hosting a website. Anyway, so I guess we could say some common ones. Well, some are going to be file storage. I guess, yeah, well, file delivery, you know, obviously like transmitting files, right, databases, yeah, like processing. So, of course, well, you can rent access to CPUs, you can rent access to GPUs. Maybe you're training some machine learning model and, you know, you don't happen to have like 100 NVIDIA GPUs. Now, rather than going out and buying 100, which of course is going to be like ridiculously expensive, of course, what you can just kind of rent them temporarily for, I don't know, you know, however many hours, days, or however long you need it for. So yeah, I guess that's going to be one good thing, right? The sort of pay-as-you-go service, right? Renting the hardware. Right, so we say, well, cloud services can be provided by a single or large number of servers. We can group these services offered into three categories. Right, so well, one is going to be, I guess, kind of renting infrastructure. So well, also called infrastructure provision. Right, that's renting hardware directly. Then there's going to be platform provision, so basically while renting different operating systems, you know, renting different kind of server configurations. Right, then software provision, so for example, well, this can be like Google Docs. I guess just kind of, yeah, using software hosted on, you know, the cloud system. Right, that can be something like NetDisk. Now, I mean, NetDisk, well, that's just like equivalent to OneDrive. Yeah, I guess equivalent to, you know, Google Drive. Just a sort of file storage or backup. Right, now, these are more commonly called, well, IaaS, right, so infrastructure as a service. Right, well, this one, right, platform as a service, and then here, well, software as a service. So let's try and think, and I mean, yeah, maybe people recognize this logo. Right, let's say a game development company wants to store the latest code with a version control system like GitHub, so all developers can access and work on the same code. So let's think, okay, like in this case, well, are they renting the infrastructure? Are they renting, I guess, the platform? Or yeah, are they renting the software? So I think in this case, I mean, yeah, it's mostly going to be software as a service. Because I mean, really, well, GitHub, you know, you're just accessing right via the website. Right, then if we look at this example, so well, an app company wants to test their latest app on every Android and iOS version. So of course, right, I mean here, what we've got two different operating systems, but you know, we've also got every single version. So I mean, that's going to be this one, right, platform. And again, of course, just renting access to different mobile operating systems. There's also some others, for example, where you can rent access to different browsers. So rather than having to have, you know, I don't know, yeah, Chrome 100, Chrome 99, Chrome 98, you know, again, Safari, like all the different versions. Well, instead, you know, you can pay a company, and like they'll simultaneously test your website on, you know, like 500 different browsers. And of course, yeah, that's going to be well quicker, right, easier than doing it yourself. Just to check there's, you know, no sort of weird, I don't know, like weird display issues or yeah, weird usability issues. Right, so the final one then, an academic department wants to rent hardware to run a computationally intensive scientific simulation and artificial intelligence project. So this is kind of like what we're saying. I mean, well, of course, right, if it's going to be AI, right, some simulation, probably they're going to be wanting GPUs, right, you know, in order to do those calculations quickly. So, right, of course, well, all right, so this is going to be what infrastructure as a service. They can rent the required CPU, GPU, RAM, right, storage capacity, etc. that they need, right, for a short period without having to buy it. And of course, well, that's going to be cheaper, right, this sort of pay as you go, right, compared to actually buying the hardware. Although, right, I mean, the thing to say with this, that if they only need it for a short period, right, then it's going to be cheaper. But if they were using this hardware for, I don't know, 6 months, 1 year, obviously, well, yeah, even longer, 5 years, 10 years, like if you're talking about sort of long-term usage, well, then it's definitely going to be cheaper to buy it. And that's actually the thing. I mean, actually, the cloud is super expensive, which, yeah, I think we'll probably see in a minute. Right, okay, so while software as a service requires the other two, you're often going to be sandboxed in, right? E.g., well, Baidu NetDisk, so I mean, I guess what equivalent to Google Drive or yeah, Microsoft OneDrive, all right, or for example, Google Docs. Then I mean, you can't really access the operating. Yeah, okay, so you can't actually access the operating system, or sort of the server configurations. So again, you're kind of operating at quite a high level. Right? I mean, you kind of only have access, right, to the actual software. Yeah, okay, here we go. All right, yeah, to the actual software that you're kind of using. Whereas if you say like, well, infrastructure as a service, I mean, if you're just renting the hardware, like hopefully they would actually let you sort of modify the configuration, let you install whatever you want on there. Same with platform as a service. Um, I mean, some of these are a bit different. I mean, like if you're renting the entire operating system, then yeah, I mean, you should be able to install whatever you want. Yeah, I guess change the configurations. If, for example, you're doing something like the kind of, I don't know, renting access to the different browsers. Well, of course, I mean, what a browser, you're going to have less customization, right, compared to actually renting access to the entire operating system. But yeah, I mean, I guess that, well, the key thing is, right, that of course, well, as we go down, right, from, well, yeah, well, software as a service, right, down to infrastructure as a service, basically what you're getting sort of less control, right, less customization each way. Yeah, and then I suppose, well, I mean, I'm down at the bottom right, just give some examples, yeah, which I think we kind of mentioned some of those already. Right, so let's look at some of the advantages then, and in particular, I think in the exam, like, I mean, although in real life, generally people talk about cloud, I guess mostly for websites. I mean, for the exam, generally they're talking about sort of companies, and, well, or let's say employees accessing their files or things like that. So here, right, okay, they're saying what an advantage of a cloud can be remote access. And we can say, well, employees can access files from anywhere. Of course, just log in with their like username, password. Yeah, maybe they need a VPN. Yeah, I guess just the company VPN, right, to log into the company system. Right then, collaboration. So employees can work on same files simultaneously. So because obviously, well, you've just got one copy of the file, on the cloud system or yeah, on the cloud server, then of course, what you can have multiple people working on that same file, right, simultaneously. And yeah, hopefully both of their changes will get merged. And again, I mean, that's going to be assuming they've got some sort of, I guess, yeah, version control system like GitHub, or yeah, if you've got, I don't know, some like video editing software, there's probably going to be some of those that, again, allow people to sort of edit the same video. Right, okay, so we say, well, it can also be used as a backup, or yeah, in particular, a remote backup. Now, of course, like, if we're talking about remote backup, I mean, now, if this is a private on-site cloud, well, then it's not going to be remote. But, I mean, if it's a public cloud, or if it's a private off-site cloud, well, then it's going to be remote. And you can think, well, what's the advantage of having a remote backup? And I think, I mean, this comes up in one of the later chapters as well. Now, let's say if you have like all of your data, and I mean, all right, so okay, like even if you copy the data 3 times, right? So even if you have, I know, yeah, copy A, copy B, copy C on, like 3 different hard drives or 3 different SSDs. Now, if this is all in the same building, well, like what if there's a fire or, a flood or yeah, earthquake, right? Yeah, there could be some natural disaster. I mean, even let's say if you're renting this in like yeah, I don't know, okay, even if you're renting this from another company, right, so it's not actually on your own premise. Well, I know there's a situation, well, for example, in like Ukraine. Now, since the war started, like I think there were a lot of websites that were hosted in Ukraine. So of course, I mean, any website that was hosted there, like, well, potentially with the war, of course, I mean, that business is just going to close, right? So in effect, of course, their website has also got turned off. So that's why, of course, it's good to have I guess what backups and copy of the data, right, in multiple different locations. Yeah, just to kind of, well, mitigate against what natural disasters, I guess companies going bankrupt, yeah, some political issues. Right, I guess, yeah, this one you can say, so a big cloud company again, well, Amazon, Microsoft, right, Google. I mean, hopefully they're going to have better security than, for example, what we could make ourselves, because whereas, well, we've got one person working on it, these companies, well, they got hundreds or thousands of people, right, just working on security, right, for their cloud system. Right, this one I put in orange because, well, some people say that cloud reduces complexity, right, compared to, for example, self-hosting, right, yeah, kind of managing the service yourself. But I mean, in reality, like I would say, yeah, maybe this is not true because I mean, again, like if you look at the actual like all of those lists of all of the different cloud services, yeah, I mean, it's kind of overwhelming, and like to actually know which one you need, yeah, again, yeah, I guess it's not as easy as what people say. And the whole point, like now you can actually get like an Amazon Web Services certificate. I think like it's, I don't know, sort of yeah, level 1, level 2, level 3. And it's like, well, if it's so easy, you shouldn't have to get like yeah 3 levels of certificates. So yeah, I mean that's why for this one I just put in orange, right? Yeah, maybe it's not that easy. Right. So as for the disadvantage, I mean some of these are quite obvious. Well, here you're storing your data with another company, and I suppose I mean right, this is talking about again public, right, or private off-site cloud. If it's a fully self-hosted, right, self-managed cloud, I guess yeah this is not really an issue. But again, right, if you're hosting with another company, well, then you have to trust them. You have to trust their security, right? Yeah, trust their privacy standards. Now, if let's say your company, I don't know, like, well, I think Tesla was a good example. Now, I know there was a case where an employee at Tesla was offered a load of money, right, to sort of steal the company blueprints, put them on a USB, right, then sell them to someone. And I think actually, well, they were offered $1 million, right, if they did that. In the same way, like if you've got some company and I don't know, yeah, let's say they're hosting with what Amazon or Microsoft or yeah, whoever else, well, of course, you've got to trust that they're not going to look at your data. Yeah, so I don't know. Well, maybe they will, maybe they won't. Right, and one, yeah, and I suppose like another thing as well, you have to think right. If this company gets hacked, well, then potentially the hacker might have access to every single person's data right in the entire network. Right, we can also say this, right, it's going to be, well, much more expensive than traditional servers. And again, right, this is in the long term. Like, if you're talking about, well, I don't know, right, okay, if you're just renting, let's say, for 1 month, well, then it's going to be cheaper because you're not actually buying the hardware. But I would say probably, like, after about 6 months, I mean, if you're using the cloud for, let's say, 6 months or more, like, honestly, I mean, yeah, you're kind of better off just to buy it. So, yeah, just to buy it yourself, set it up yourself. Right, well, some software also can be run effectively when distributed across multiple servers, right, e.g. databases. Yeah, it's going to be hard to, keep them in sync, right, if you have multiple copies of the same database. Right, and again, well, less customizable, right, less control, e.g. compared to having your own servers, right, and managing them yourselves. Right, so actually, this one is not required for the exam. However, this is maybe if, some people are interested in setting up their own setting up their own website or something. Right, if you're not, then honestly you can just skip this, right? Yeah, maybe it's just going to confuse people. Right, so an alternative to a cloud is VPS, right? So VPS, well, virtual private server. I guess you can also get dedicated servers. Now, a dedicated server, that's going to be more expensive. In that case, where it's dedicated, right? I mean, that means only you access it, right? Only you own it. If you have a VPS, well, a VPS basically, right, okay, in this case, you're going to have, well, one server, and right, this server is shared between many different customers. I mean, so for me, like, well, this is what I'm using, for the Pseudocode website. I think I'm paying about $6 per month, and yeah, I think that's going to give me like 32 terabytes of bandwidth. I think actually, I mean, the RAM is quite low. I think the RAM is only 2 gigabytes. I think the storage is like 30 gigabytes. So I mean, it's not that good, but again, it's $6 a month, right? It's not that expensive. Right. So in contrast, well, in the cloud, you're paying for usage, right? Kind of pay as you go. So you could be using one server or you could be using 1,000. Right, the good thing is, well, the cloud provider will automatically create and remove servers right, as your demand changes. So we can say, well, it's going to be scalable, where it's going to automatically scale up, and hopefully it's going to automatically scale down, right, as your demand changes. Though the disadvantage of this, well, this can be hundreds of times more expensive than if you again just to just to buy or rent the hardware yourself. So that's why some people always go to the cloud, but I mean, yeah, you kind of have to think about the price. And I think in a minute I guess there'll be some examples maybe. Yeah, okay. All right, so here then we say, well, the cloud, right, the advantage, well, highly scalable because we can, well, create new instances automatically when demand surges. And you can think of, let's say, like an e-commerce website, right? This is a common example they always use. Now, maybe on a regular day, I don't know, they have, okay, I mean, let's say it's a pretty big company, right? Let's say like 1 million or 10 million. I mean, let's say like 1 million customers. Right. However, let's say, for example, you have like, I don't know, like maybe Boxing Day. So maybe on Boxing Day, what, the 26th of December, well, people have like just got their Christmas presents, you know, they got some vouchers or whatever. And of course, right, on that day, everyone is going to go online, right, on Amazon. And like, maybe that day, what, they have 10 times more people than usual. So in that case, you're thinking, well, would you just want to always buy like 10 times more servers than what you need? And of course, what I mean, then for like 99% of the year, you know, the servers are just running at 10% usage. You know, so obviously that's not going to be very good. Whereas like if instead you have the cloud, well, then of course what I mean what you can do, well, of course, right, you can just have however many servers you need, right, for normal usage. I don't know, let's say like 1,000 servers. But you know, on this one day when it becomes super popular, well, then it's going to automatically scale up to, you know, 10,000 servers or whatever you need. So yeah, I mean, while this is convenient, right, again, you have to think about the price, and I mean, this is going to be super expensive, right, to have this, yeah, kind of automatic, like automatic scaling features. Right, so because of this, well, variable pricing, this can result in huge bills, and there's actually, well, like thousands of cases of this. Or like, let's say you have a small error which causes an infinite loop. And I mean, well, I think infinite loops, you know, anyone that's done programming, I mean, yeah, I guess, you know, creating infinite loops is, you know, super easy, right, super common. Yeah, it's not something that's difficult to do. So there's been cases where, like, you've literally had someone that's created a simple infinite loop, and like this has literally cost them like $10,000 in 24 hours, just because, well, I mean, all of their CPUs were maxing out at 100%. And I mean, like, this is, yeah, and all right, and so like when we say this, right, this is not talking about some huge company with like, you know, billions of dollars like yearly revenue. Like this is literally just like one random person. So yeah, obviously, well, when, yeah, I guess like when you wake up in the morning, right, you see this huge bill. Yeah, I mean, well, you're probably like not going to be too happy. Same for example this, I mean, all right, so my website also had this, well, a DDoS, right, a distributed denial service. Now, since I was using a VPS, like what happened, I mean, basically the website was just offline for about 2 weeks. However, well, if we see in a minute, right, I mean, let's just erase this. And all right, yeah, all right, so okay, let's go here. So right, since I had okay, yeah, all right, okay, so when I had the DDoS, I mean, since I had the fixed price, then what happened? Well, basically the website just went offline because, you know, I guess too many people trying to access it. But for me, you know, I was still paying only $6 per month. Whereas if, for example, I had the cloud, which was going to automatically scale, well, then you'd have it where, I mean, I don't know, right, let's say my one server would have automatically scaled up to like 1,000 servers, and you know that, well, then I probably would have woken up with like $100,000 bill, or, you know, something crazy like that. So of course, I mean, that's going to be the good thing about the VPS, right? I guess it's kind of reassuring. So yeah, because these fixed resources, right, you can't scale up, right? Therefore, well, that's reassuring. But also VPS generally is going to be more customizable than the cloud as well, since generally you have sort of more direct control over the operating system, whereas yeah, generally the cloud, it kind of operates at a higher level. Yeah, some of, for example, like AWS, right, they're going to abstract away some of the operating system details from you. And I suppose, right, if we look at the contract duration, well, cloud rate's going to be pay as you go. So if you only need to rent the cloud for 1 hour, well, that's all you pay. Whereas something like a VPS, right, usually the shortest contract is going to be about 1 month. Now, again, right, I mean, okay, right, so yeah, right, if we say, well, cloud is going to be on the syllabus, right, VPS, well, that's not on the syllabus. Although if you think VPS, I mean, basically it's just like a traditional server, right, what people would think of as being a server. So I mean, really, like, this is only for people that are interested in, you know, maybe making a website or making some app which they, yeah, need to communicate with a server. All right, now if we go on to this part, well, this is in the syllabus, right, bit streaming. So let's think then, well, what does a stream or streaming mean? So, and that can be, well, either in computer science or yeah, also geography. So I think, you know, probably a lot of people know this, and I think we have a picture as well. Right, so what a stream is going to be accessing a constant flow of data, right, e.g. a live video, phone call, watching a movie. Now, I suppose, like, when we say a movie, well, this is like a live movie, right, like an ongoing movie. Right, again, I guess, well, streaming music, so of course, yeah, kind of live music. Right, however, unlike a regular download, a stream is of unknown or, yeah, possibly indefinite length. Because, right, okay, so if we think, right, if you're watching a regular movie, I don't know, on like Netflix or something, well, let's say what that movie is like 4 gigabytes or, yeah, I don't know, 2 gigabytes, whatever size it is. Whereas let's say if you're watching a live video, well, maybe that video is going to go on for 10 minutes, right? Maybe it's going to go on for, you know, 5 hours, right? Like some Twitch stream or something. I mean, it could also be, I mean, some, yeah, I guess, you know, some live streams are like 24/7, right? It could be CCTV. Yeah, I think there's some. I mean, there's some cases where people have literally just put like I guess, a camera like in the middle of some city. Of course, yeah, just watching the people go past, right? Things like that. So that's going to be the difference, right? A stream is basically going to be of unknown or indefinite length. And of course, what I mean is similar to what a stream is in like a small river. Or of course, what I mean, the water is flowing. Whereas in this case, what it's going to be a flow of data, right? A flow of bits. Right, so then there's going to be two types. It's going to be on demand and real time. So on demand, this is streaming from a source that already exists. So yeah, okay, all right. So when we say a source that already exists, I mean basically what this is a video or audio that's already been recorded. So for example, like Netflix. Well, I mean, of course, you're not watching the video live or as it's being directed. I mean, yeah, of course, right. This video has been made, it's been released. All right, so yeah, that's kind of what that means. Right, then if we say real time, well, this is streaming from a live source. So, yeah, I guess kind of like here, right? I mean, if you're listening to these radio stations, if you're watching a football match, right? If you're watching, yeah, I don't know, Twitch or yeah, whatever, streaming website. All right, so yeah, let's try to think of some examples, and I guess I've said a few of them. So on demand, well, pre-existing media. So I guess, well, I mean, this YouTube video, for example, right? SoundCloud, Netflix. I mean, of course, YouTube also has YouTube Live as well. So YouTube is going to support both. And then, well, real time, of course, well, live sports, Twitch, right, radio. So let's look at these and, well, let's try to think, okay, which are going to be on demand and which are real time. So you can pause the video. I think, yeah, people should, recognize a lot of these. So if we look at the first one, well, of course, I mean, the first one's just 2 YouTube videos. Now, it's probably a bit difficult to see, but if we see this first one actually says live, right, so that's going to be a live stream. Of course, well, I mean, this second one, right, we see what that's got a length of about 49 minutes. So, of course, that's going to be on demand. Likewise, well, of course, Breaking Bad, well, that's what a TV series, right? That's going to be on demand. Right, if we're talking about video calls, right, so Zoom, yeah, I guess, yeah, I guess other ones as well. Obviously, well, that's going to be real time, right, since it's happening, yeah, kind of live. I mean, here, I guess, well, yeah, live flight tracking, right, therefore it's going to be real time. Obviously, while watching some football match, right, again, it's going to be real time. Now, if we're torrenting, so, well, torrenting, remember, peer-to-peer. So peer-to-peer, well, in this case, what the file has to exist, right? The file has to be on their hard drive or SSD. So because the file has to already exist, well, that's going to be on demand. And then likewise, well, I mean, this one, QQ, I mean, well, this is just QQ music. So I guess, same sort of Spotify, iTunes. So of course, well, again, right, that's going to be on demand, right? Since, well, in that case, the music has to already exist. Right, so let's have a kind of more detailed overview then. Right, so on demand, well, media files are stored on the server and they're converted, right, to a streaming format. Because of this, well, we can pause, rewind, fast forward, right, etc. Again, right, since the videos are stored on the server, right, they already exist. Right, often they're going to have better quality since if you think, well, we can buffer these, and if this has already been recorded, then of course what we can do, well, we can kind of like preload like the next 30 seconds. So because we can like preload the video or preload the audio, then generally we're going to be able to support better quality or a higher quality. Again, since we can just load that data in advance. Whereas if we're talking about real time, well, maybe real time, we're not able to support like that high quality data, or I guess like maybe real time we're not able to support that bandwidth coming in constantly. Well, that's probably a terrible explanation. Okay, so right, let's say that this line here is the, I guess, required bandwidth we need, and let's say, I don't know, or maybe 10 megabits per second. Now, if you're talking real time, well, like maybe sometimes your network is, 12 megabits per second, or of course that's going to be fine, that's going to be fast enough. But, sometimes, of course, it's going to drop below this. And then, like, if we have a real-time stream, of course, well, when our network drops below the kind of required speed, for the stream, or the required bandwidth for the stream, well, then, of course, right, I mean, well, okay, basically, we're just going to lose this data. Right? I mean, it's not going to play that video, or it's not going to play that audio. So, of course, right, I mean, that's going to be a problem with real time. And then, I mean, hopefully it's going to come up again. And then, of course, well, I mean, from here, right, we can start, watching the video again. Now, if instead you think, right, if this was, okay, all right, so if this was on demand, well, the thing is right here, like, if we're downloading this part at, 12 megabits per second, well, what we're actually doing then, we're kind of like buffering extra video just for the times where, when the connection kind of drops or gets a bit slower. Well, in this case, I mean, we're actually getting sort of more video than what we need, right? So, all right, so I guess we're kind of preloading, right, pre-buffering the video. Yeah, therefore we're going to be able to sort of watch the video without interruptions. Yeah, I mean, hopefully that makes sense. Yeah, maybe not, but I guess we'll see in a minute about buffering. All right, so in contrast then, real time, well, of course, right, captured in real time and the live media is sent. Right, it might not be sent. Okay, it might not be saved on the server. Now, in the exam, they say what is not saved on the server. However, in real life cases, often it is because, well, often I guess, yeah, you can watch a live stream. And then of course, well, that live stream will then be saved, and you can watch it back later. For example, like on YouTube, right? I mean, YouTube, you can like rewatch the live. Yeah, you can rewatch the live streams. But I guess if you're just talking about a simple setup, well, a simple setup, I guess it's not going to be saved on the server. Yeah, it's just going to be sent in real time. And once it's been sent, well, then it's yeah, I guess like I said, once it's been sent, well, basically it's just gone at that point. Right, because of this, like, well, of course, well, then we can't rewatch, we can't pause, yeah, we can't, I guess rewind, fast forward. I mean, well, yeah, I mean, obviously, fast forward, we definitely can't do, like, well, not into the future anyway. And then, well, I mean, so this is kind of what we said here, right? So packet loss, because we're using UDP, can be an issue. So parts of the video or audio will be lost. Well, obviously, like for example, in this place, right, when we're receiving data slower than the actual kind of bit rate of the video or audio, right? Well, then of course, I mean that part of the video is gonna, I don't know, maybe it's gonna jitter. Yeah, maybe it's just gonna not play at all, right? Yeah, whatever. All right. However, again, like in reality, I guess it's slightly more complex than this. A lot of media players, right, they do have kind of more advanced features. So some media players, right, they could, for example, all right, okay, let's say they save the last 30 minutes of played media on the disk, and then because of this, well, that's going to then allow you to pause, rewind, right, etc. However, right, if you're talking about the exam, well, just say, yeah, I guess like for the exam, they're just talking about more simple. So yeah, just say, well, in that case, well, you can't rewatch it, you can't pause it, right, you can't fast forward. Yeah. Right, so if we look at actually bit streaming, how this works, so first the media player is going to request data from the media server and it's going to store it in the buffer. Right, the media player is then going to play the video as it arrives in the buffer. Right, if the buffer reaches the high watermark level, then the media player tells the server to stop sending. If the buffer hits the low watermark level, the media player tells the server to resume sending. Alright, so what that's kind of saying, I mean, like if you just think of like YouTube, I mean YouTube is well, I guess everyone knows that. So like if you think, okay, well, when you're watching a video, right, okay, so let's say this is like the current time we've watched, and well, I think this is like usually red. All right, then you have what, the gray part. So the gray part, this is going to show how much of the kind of, I guess, future video that is already loaded. And I mean, what often this will be, I don't know, maybe 30 seconds in front. So it's kind of why it's pre-loaded, right? It's pre-buffered, right? An extra 30 seconds of video. And then what this is saying, so what it's going to do is okay, basically the media server is going to keep sending video, right, until the buffer fills up to this high watermark level. And to be honest, actually this diagram is kind of the wrong way around. Really, this high watermark level should be here, and yeah, the low watermark should be here. So like let's actually draw it this way. All right, so let's say this is the MS, this is the media server, and well, this is us, right? This is I guess the video, right? The media player. So of course, I mean the media server, this is just sending video. Let's say here, right, this is the high watermark. Right, this here is the low watermark. So since currently, all right, okay, yeah. So okay, all right. So let's start from the beginning. Right, currently, there's nothing in the buffer. So because there's nothing in the buffer, then I guess the user, right, the media player, is going to send a message to the media server, basically asking for it to send data, right, send video. So of course, I mean this media player is going to, the media server is going to start sending the video. Right, of course, I mean, all right, so here then, all right, that's going to fill up, the buffer, and of course, as the buffer is filling up, right, of course, this is also going to get played at the same time, right, simultaneously, right, of course, okay, all right, so this is going to keep filling up, right, when it then gets to the high watermark level, so of course, right, this means that the buffer is nearly full. Well, then in this case, let's say the user, right, I guess, more particularly the user's media player. So the user's media player is then going to send another signal to the media server, and this signal is just going to be to stop sending, right, since the buffer is nearly full. So of course, yeah, right, then the media server is going to stop sending, right? But if we think, right, okay, so the video is still going to resume playing, or it's still going to continue playing. So of course, as it's playing, well, I mean this, right, okay, yeah, this level in the buffer is going to decrease right as the video is playing, and of course, what eventually it's going to decrease back down to the low watermark level, and of course, well, I mean, as you can probably imagine, right, as it gets to the low watermark level, well, then of course, what the user's media player again is going to send another message right to the media server, and of course, that's going to start sending data, yeah, just filling it back up again to the high watermark level. And like if you think about that, I mean again, right, you can just see it on YouTube because, well, I mean, right, if you just look at the playback bar, well, I mean, you see the current time, and then like when you only have a little bit of sort of preloaded video remaining, well, then of course, what I mean, YouTube is going to load more video again, and of course, right, you're then going to see this kind of future buffer. Yeah, of course, right, that's going to increase. Yeah, I mean, so hopefully that makes sense, right? What that's saying, right? Just preloading the video. Now let's try quite a difficult problem from the book. It says, consider a bitstream scenario for a video where the following values apply. The buffer size is 1 megabyte, the low watermark is 100 kilobytes, the high watermark is 900 kilobytes. Right, the incoming data rate 1 megabit per second and video display rate 300 kilobits per second. Right, we can assume the video is playing and that the buffer content has dropped to the low watermark level. Alright, so what the low watermark, that's what this, okay, here we are. Right, okay, yeah, this 100 kilobytes. Right, the media player sets the controls for data input to begin again, and we want to calculate the amount of data that will be input to the buffer in 2 seconds, and the amount of data that will be removed from the buffer in the same time period. Right, then it says, well, repeat for 4, 6, 8, 10, and 12 seconds. I mean, this one, yeah, where is the pen? Okay, here we go. Yeah, I mean, I think, well, this one we won't do, right, since, of course, just multiply by 2, right, multiply by, yeah, 4, 6, 8. Yeah, it's quite, quite easy, right, but just tedious. Right, then from this data, estimate when the buffer will have filled up to the high watermark, and assuming that the incoming transmission is halted at this time, calculate how long it will be before the buffer content has again fallen to the low watermark level. Now, I guess, I mean, this part was kind of like 3 questions, so yeah, where is the pen again? Okay, right, there it is. So of course, I mean, this is what question 1, question 2, then yeah, question 3. Now, actually, we can do this question 2, without having to use this data. Yeah, we can just calculate directly. So, right, let's think how we can do this then. Right, how can we calculate how much data will be input into the buffer in 2 seconds? Now, of course, while here, right, okay, so we say, in 1 second, it's I guess, yeah, 1 million bits, right, 1 megabits. But if we actually look at these, well, I mean, here they're actually using kibi bytes. So, yeah, so what I'm going to do, well, I'm just going to convert everything into kibibytes. Now, you could convert into mebibytes, because you see, right, this is using mebibytes. However, the thing with this, well, one, we're actually not using the buffer size. And the problem with using mebibytes in this case, right, it's going to get a bit tricky because, well, we're going to have numbers, I don't know, yeah, 0.00, so I guess, yeah, the numbers are going to be quite small. Whereas if we use kibibytes, right, it's going to be more reasonable. Yeah, just, more kind of, well, I guess numbers that we're more familiar with. Yeah, less decimal places. Right, so here then, I guess if we just want to convert this into kibibytes, what we want to do, so it's going to be 1, then we do times 10 to the 6, because of course, mega, right, that's million. So that's going to be a million bits. But then to convert into bytes, well, first we have to divide by 8. Right, then we want to, right, okay, yeah, well, then we also want to divide by, 1024. Because of course, it's going to be 1024 bytes in a kibibyte. Now, if you do that, and of course, right, so right, this is going to be how much data is coming in for 1 second. Right, of course, if we want 2 seconds, well, of course, we can then just multiply that by 2. Right then, I mean, well, for the video display rate, we can just do the same. But of course, well, rather than going 1 times 10 to the 6, right, in that case, well, it's going to be 300, right, times 10 to the power of 3, right, since it's kilobits. Right, and then, well, of course, in this case, it's going to be the same, right, 8 times 1024. So if we do both of those, that's going to be, 122.1 kibibytes coming in per second, and 36.6, right, kibibytes going out per second. Of course, if we want 2 seconds, just double, or if we want 4, of course, yeah, multiply by 4, etc. Right, so then 2, from this data, estimate when the buffer will have filled up to the high watermark. So I guess then we just want to calculate the difference, right? So, well, of course, the difference, this is how much data is coming in, right? This is how much data is coming out. Of course, if we just subtract that. So I guess if we subtract that, I mean, yeah, I don't know what it's going to be, right? I don't have a calculator. But I think, well, I mean, all right, so I think I remember, like, it's about 85. So what you then want to think is that, right, well, yeah, okay, so you just want to look at the difference between the low watermark here and the high watermark. So if currently we're at 100 kibibytes, but we want to work out how long it's going to take, right, until we fill up to this, well, 900 kibibytes. Well, of course, right, first we want to work out the difference. So the difference between them is 800. So basically we're saying, well, how long is it going to take us, right, to get, 800 more kibibytes coming in, right, than we've, like released out or, yeah, played out. So of course, well, in that case, right, yeah, okay, right, yeah, here's the pen. Right, so it's going to be, what, 800, right, divided by, well, this 85 point whatever it is. So yeah, that's going to be this one. So I guess, what, 122.1, right, minus, yeah, I guess this. Well, that's going to be 85.4. And well, I guess, here I've done some rounding, right? I mean, if you don't have the rounding, yeah, then it's going to be 85.4. Right, then, of course, if you do, what, 800 divided by that, right, that's going to be approximately 9.4 seconds. Right, then the last one, so assuming the incoming transmission is halted, calculate how long it will be before the buffer content has fallen again to the low watermark level. Right, so of course, what in this case, what we're saying, well, currently then we have 900, right, since we're at the high watermark. And then we just want to calculate, well, how long is it going to take? And of course, right here, we don't have any video coming in at this point, right, since we've reached the high watermark. Yeah, it's just going to stop. Right, so of course, we want to work out how long is it going to take for that to reduce back down to 100. And of course, what I'm here, so again, the difference is 800. And then in this case, what the outbound speed is, well, 36.6. So if we just do, what, 800 divided by 36.6, alright, that's going to tell us how many seconds. And right, that means it's going to take 21.8 seconds to drop to the low watermark. Now, I mean, while I have seen them ask questions like this before, I think, I've not seen them ask a question like this for a while. And I mean, some people did actually say that bitstream is not in the syllabus anymore, although I did just check before I made this video. And I mean, yeah, they were, alright, so like they do still have it in the syllabus. So in theory, I guess they could ask this, although yeah, it's probably, not that common, right, quite difficult. Right, so I guess let's try another one. So you're designing a media player to play videos with a resolution frame rate of, well, 1920 by 1080, 30 frames per second, and a color depth of 24, right? Assume with compression the file size reduces by 50. Now, this question they wouldn't really ask since, well, videos they have removed. But, I mean, I think videos wise quite easy to calculate the file size. Well, of course, it's the resolution, right? So, well, this here, the resolution, right, that's going to be the number of pixels in the image, or, yeah, I guess, in each image. Right, then, of course, we're saying, well, okay, right, then we've got 30 images per second. Right, then, well, I mean, here, well, this is just how many bits are used for each pixel. So if we just, well, multiply 1920 by 1080, right, times 30, right, times 24, that's going to tell us how many bits for 1 second. Right, then I guess what we can, right, okay, so yeah, right, so, well, then if we divide by 50, right, since we're saying, yeah, compression is going to reduce it by 50, right. So what we want to do, we want to stop requesting data when we have 2 minutes of video stored in the buffer, and start requesting data when there's only 30 seconds remaining in the buffer. So from this, what size should we make the high and low watermark level? Right, okay, so I guess here then, what we said, right, this is going to be our size for 1 second. So of course, I mean, yeah, all of these multiplied together, right, then, yeah, just divided by 50. Right, so that's going to be the number of bits for 1 second. I guess what then, if we just multiply that by 30, right, that's going to give us, what, the number of bits for 30 seconds. So, I mean, that's right, that's going to be our low watermark level. And of course, if we want 2 minutes, well, of course, well, yeah, rather than multiply by 30, of course, we'll multiply by 120, right, since, well, 2 minutes, right, 120 seconds. Now, that's going to work, of course, that's going to be in bits. Now, probably we would want this to be in, let's say, like, mebibytes. So, of course, well, right, to go into mebibytes again, we'll take that answer. Well, then you're going to want to divide by 8, right? Then you're going to want to do, well, I guess 2 to the power of 20. Or, of course, 2 to the power of 20, right? You can also write as 1024 squared, since, I mean, yeah, they're going to be equal, right? Since 2 to the power of 10 is 1024, right? Therefore, 2 to the power of 20, well, 1024 squared. Right, and then I guess if you do all of that, so, well, high watermark is going to be this, right? Low watermark, right? That's going to be that. Right, so finally then, let's just look at some of the advantages, disadvantages of bit streaming. Right, so a good thing, well, we can play the video immediately without having to wait for the whole file to download. Whereas, let's say if you, I don't know, you were like torrenting, right, doing some peer-to-peer but a download. Yeah, if you were, I don't know, yeah, downloading from, I don't know, some video website, of course, right, you'd have to, or yeah, download from iTunes. You'd have to wait for the whole video, the whole audio to finish. Whereas, of course, yeah, in this case, we're just going to start streaming from the start of the media. Right, another advantage, well, we also don't have to store the large files on devices. And of course, well, I mean, while that's good for storage space, it's obviously not good in the fact that we actually never actually kind of own those files. We never actually have them on our device. And I guess we'll see here, like, well, because of that, of course, well, that means we're going to require the internet, right? Since, well, right, of course, we're not storing them on our device. Right, then if we look at another advantage, and of course, well, this is an advantage, for the actual kind of copyright holders, right, for the creators, it's going to be harder to pirate, since saving streams, or I guess, yeah, I don't know, I guess kind of downloading streams as files, saving them as files, is going to be harder than, of course, if we just like download, a song from iTunes. Like, even though a lot of these things, well, I mean, I guess a lot of them are going to have some sort of DRM, right, digital rights management, which in theory this makes it difficult to copy. Although to be honest, I've not really had much experience with things like that. Right, so the next one, well, right, another disadvantage, right, okay, is so if we're streaming, then it can buffer lag on slow connections, right, or for example, if we're watching a high resolution video. Whereas of course, like if we've actually pre-downloaded it, well, then of course we're not going to have that issue. Right, also it's going to use lots of bandwidth. Now, I guess this is not really true if you're, just streaming it once. But if, for example, you're streaming the same song 100 times, because, well, of course, right, a lot of people do this, right? Let's say they're listening to Spotify, right? Like maybe they just have, certain songs that they kind of listen to over and over again. Well, of course, in this case, you're using, 100 times more bandwidth, right? Rather than if you just downloaded it and saved it once. All right, so I think now that let's have a recap, right? Let's try to define cloud computing. So as always, right, pause the video, have a go, see if you can do this. Right, so this one we said is the provisioning of computer services via the internet. So quite simple, of course, we're just renting, renting resources. Right, that can be CPU, RAM, storage, right, GPU, right, etc. I guess, sort of, network connections, right, bandwidth. Just renting whatever resources you need. Right, then we want to list some advantages and disadvantages of a company, of using cloud computing to host their files or software. So again, right, pause the video, have a go. Right, so if you've done that, some advantages, well, one is going to allow remote access, so employees, they can access from home, they can access, right, while they're on holiday, whenever. I guess also any time, right, maybe there's like some, fault at like 2 a.m. in the morning, and rather than them having to come into the office, well, of course, they can, try and fix it from home. Right, of course, collaboration, so you can have multiple users, working on the same files. Since you've just got like, I guess, well, right, okay, so I guess you've got sort of one main copy. Although, in theory, if you're talking about like a good backup strategy, of course, you should have multiple copies, and ideally, right, in different physical locations as well. I suppose that's going to be this one, right, remote backup. I guess remote backup, I mean, you can just use the public cloud for that. You can also use a private cloud in an off-site location. Right, better security, I mean, hopefully that's true. Again, it just depends on the cloud service. But if you're talking about Google, Amazon, Microsoft, I mean, well, again, hopefully these companies should have good security, right? They've got hundreds or thousands of people, right, working just on security for their cloud systems. And then again, well, this one right in orange because, well, maybe it does reduce complexity. However, again, if you look at the huge list of different features they have, I would argue that this is maybe not true. Right, however, the disadvantage is, well, you're going to have security, privacy concerns. And I mean, I guess security concerns, I mean, that kind of goes in contrast with here. This, of course, just depends. I mean, you might think, well, maybe it's going to be insecure because, let's say, like, if one device gets hacked, then, well, in theory, I guess, maybe that, that can spread to other devices, like on, in the cloud network. I mean, hopefully that's not going to be the case because, well, really, they're probably running on their own virtual machines. I mean, you're going to have, various subnets and things. Right? Of course, there's going to be ways for the cloud company to kind of separate out the network so that, if one device gets infected, well, that shouldn't be able to, then infect like all the other devices in the cloud system. So again, I mean, this security, well, just depends really on the actual company. I mean, privacy concerns, well, this is always going to be an issue because, of course, well, you're hosting your data on someone else's machine. Likewise, well, loss of control of data, right, that's the same thing. Right, this one is going to be expensive. Now, I suppose what if you say if you just need to rent, for like I don't know, yeah, for sort of like let's say 1 month, well then it's going to be cheaper. But if you're talking, 6 months or years, right, then it's going to be more expensive compared to just like buying or sort of renting the hardware directly. Right, so some programs can be distributed easily or at all. So, for example, some databases, right, it's going to be hard to distribute them across multiple cloud servers. Um, right, it's also less customizable, and I guess you have less control over the hardware, right, less control over the configurations of the software, right, compared to, okay, so compared to if you were just, hosting it on your LAN or, hosting it, with a private cloud, right, in your own system. Then let's list some reasons why someone might choose a public versus private cloud and vice versa. So for public, well, it's going to require less expertise and also doesn't require the expensive setup and hardware costs. However, we did say it's going to be more expensive in the long term, since, well, of course, basically you're paying for another company, rather than, for example, hosting it yourself. Right, however, it might be more secure than own solution. And again, this one is in orange because, well, maybe this is true, maybe it's not true. It just depends on the situation, really. Right, I mean, so private, well, of course, right, it's definitely going to be more private. I mean, higher privacy since, I mean, well, you're storing the data, right, just on your own systems. Because you're using your own systems, you therefore also have more control. It's also going to be cheaper in the long term, right, once you've actually purchased the initial hardware. And because they're your own systems, they're also going to be more customizable. Right, for example, you can buy the specific hardware you want. Of course, you can configure it, right, in the exact way that you require. Finally then, let's just explain the difference and advantages, disadvantages of on-demand and real-time bit streaming. So again, if you've paused the video and had a go, well, on-demand, we say the media is created in the past, it's then converted to a streaming format and streamed to the user. So because of this, well, the user can then, pause, rewind, fast forward, etc. Right, also, well, because of pre-buffering, then hopefully we can actually get, a high quality stream, right, high quality playback, right, video, audio. And again, well, that's because let's say the video has, an average bit rate of, I don't know, maybe let's say like 10 megabits per second. Now, we might have sometimes where, let's say our network quality is, 15 megabits per second. So, of course, in that case, right, we can pre-buffer the video. And then if other times it goes down to, 8 megabits per second, well, that's not going to matter since, when it was 15 megabits per second, like we've, of course, so basically what we've loaded more video, we've buffered more video than what we need. Whereas, of course, if you're talking about, real-time streaming, well, if the real-time stream is, let's say, 10 megabits per second, then if our actual network speed goes, so if our network speed ever goes below that, well, then, of course, those frames or that audio, right, we're just not going to receive that. Right, however, I mean, I guess, well, this is a disadvantage for the actual hosting, hosting company, like, Netflix, for example. Right, it's going to require lots of storage to store content, and, I suppose for YouTube, right, it's even more extreme. Right, then real-time, well, so this is the live playback of the event, so I guess that's kind of the good thing, but some of the bad things, well, we can't pause, rewind, fast forward. Also, if we get, dropped or unsent packets, and we can say unsent because, maybe too many people are watching the stream, and I guess the server is not actually able to send it to everyone, where there's too much network congestion. Then because of that, we're not going to be able to play that part of the stream, right? It's just going to get cut out. Alright, anyway guys, I think then that's the end of this video. As always, if you have any questions, ask in the comments, and hopefully I'll see you in the next one.